All right, question 19 asks, in order for an alpha helix to span a 30 angstrom thick bilayer, how many amino acids must be in the helix? How about if we had a beta sheet instead crossing that bilayer? All right, so in any calculation question like this, it's often helpful to write down the information you have. Usually you want to start off with the information you have and add to that conversion factors, stuff like that. So, a single bilayer here, we're saying this type of bilayer is 30 angstroms across. All right, so what is the relevant information about either a alpha helix or a beta sheet? Well, the relevant pieces of information are, first of all, how many turns of a helix give what height, basically. So we call this the pitch of the alpha helix, and we learned about this way back in chapter 6. All right, so the pitch of an alpha helix, for every turn, one turn basically occupies 5.4 angstroms. So if we do this calculation here, 30 angstroms divided by 5.4, let me get my calculator. All right, we get that we have, it's going to take 5.55, repeating, turns of an alpha helix to cross that membrane. Well, the question isn't about how many turns, it's about how many amino acids. All right, so we also have that conversion factor in chapter 6. So we have 5.55 turns, this is the number that we have. All right, and we know how many amino acids there are per turn. The answer is there are 3.6 amino acids per turn. All right, so if we take the 3.6 here and multiply it by our 5.55, all right, we end up with, we need 20 amino acids to cross that bilayer. All right, now how about a beta sheet? Well, a beta sheet is in the extended conformation. So 30 angstroms here. We're not talking about turns anymore, right? The number that we learned for a beta sheet is that basically every 2 amino acids extends a distance of 7 angstroms. So there are 2 amino acids for every 7 angstroms, and so we can do this conversion, use this conversion factor right here. Right, and we get an answer of roughly 8.6 amino acids are needed for a beta sheet to cross this particular lipid bilayer. And that is it for question 19.